Okay, what we have here is the Husky. It's a 20-inch tread plate toolbox. It's 20 by 8.9 by 9.7 deep. And that is our Faraday cage slash test cell. So what we have in here is the impedance matching network. Of course, the spark gap. We have a terminal strip over here. The top is RF grounded right here. It's connected to the bottom box. This hinge you can't depend on being very well grounded. This is a BNC bulkhead fitting. That goes, and nothing's hooked up right now. It's just a demo of how things work. Goes down over here for the, okay, one is an antenna. This is basically a coax cable. The outer plastic and well as the aluminum foil screen is stripped off, so all you have is the inner copper connector with the insulation on it, and I put another tube to help insulate it from any high voltage. It's going to be laying on these coils. They're high voltage coils. So this bulkhead fitting goes down inside here. Yeah, let me see if you can see that. Yeah, maybe you can see it from the back better. You know, the ground strip goes in the bottom. Coil. We got one. We got two of these. One is an antenna for the the scope, and the other one is a one loop coil. Same thing with a BNC connector on the end for the voltage and a frequency meter. Yeah, turn it around here. In the back we have the neon transformer is installed, and you know the BNC fittings right here. We also have some jacks. These are the banana jacks. When we were running the flyback transformer, we were running 12 volts pulse through it. PWM was on the outside. We also have some jacks for pin jacks. You can put your voltmeters, frequency meters, check connections with the circuit. Okay, we have some grommets right in here for the high voltage leads from the neon transformer, and this one's actually has a adjustable duty cycle on it. This is a 110 volt unit. It's actually got a switch but right in here. You can hook up the ground fault here if you want. We're leaving it unhooked. This is the J8000D. Johnny Austin Neon Company makes it. 8,000 volts at 30 milliamps, and you can see it's got a secondary ground fault circuit here, which we don't really want to work. When you're running radio frequency, these actually can transmit on out, so you want to stay away from that side of the box. Also, this is for the RF ground here. This grounds the whole box, as well as we had the green wire went up and grounded the top of the box, so everything was grounded. If you don't use a Faraday cage, you're going to be transmitting into the environment, and you could be getting a visit from the police. They could use the excuse they have a domestic dispute and they got a 911 call. They've done that baloney on me before a few times. So I got wise and decided I'm going to start putting all my stuff in a Faraday cage, because I'm obviously probably transmitting into the environment and disturbing some legitimate radio operators. So don't want to get in trouble with the FCC. These fines can be very, very expensive. I've never been fined, but I've heard of one operator getting like a $34,000 fine, having a GPS jammer in his car because he didn't want the boss to know where he was. So you don't want to do that. The other reason you want to run the Faraday cage is keep the RF inside. You're going to get health problems if you get enough exposure. That means anybody that's running Tesla coils, any of that stuff, running high voltage or high frequency, this stuff can cook your brain, cook your eyes, you can cause you blindness, make you sterile, a lot of health problems. You don't want to be involved with that stuff. So any extended period of time you're running these coils, you need to run it in a Faraday cage. Otherwise, you're going to pay the price. So there you have it.